Hello dear students, I am Dr. Moinuddin. In this video we are going to learn about instrumentation of thermogravimetry. So apparatus used in this technique, thermogravimetry, is called thermobalance, and it has four major parts. And what are these? The electrobalance and its controller, the furnace and temperature sensors, the programmer or computer, and the recorder or plotter. And here is the schematic diagram of thermogravimetric analyzer. So you can see here's a sample pan, and that is attached with the balance, and the balance is further attached with balance control unit. Now sample has been put in furnace to supply heat, and this is the place where we can control the atmosphere. Mean we can heat our sample in the controlled atmosphere. So for this purpose we can put gas inside from here, and even if we want to study our sample in vacuum, so we can create vacuum by flushing out gas through this hole. So temperature of the sample is noted by using sensors, and these are thermocouple here, and these thermocouples are further attached to the recorder to get final results. So the first part of TGA instrumentation is the balance. It is generally a modified electronic balance. So electronic type of balance, it's the modified version which is being used in TGA apparatus. Sample size and in what range we can use sample. So these ranges from few milligram to 30 gram. And there are some precautionary measurements which we must have to take in this apparatus. And what is that? The presence of corrosive or oxidizing gases near balance is most undesirable. So balance enclosure is often purged with an inert gas such as nitrogen at room temperature. So if we put some oxidizing gases, so definitely it may cause damage to our balance. So we must have to take care of about these precautions. So let's see now the working of this balance. So there is a lightweight arm, and that is pivoted about an electrical coil, and this one is suspended in a magnetic field. The position of the arm, so the position of the arm of this balance is measured by an optical sensor. Any deflection definitely whenever we put some substance or some compound on it, so there will be deflection on this arm. So any deflection causes a current supplied to coil. So whenever we put some substance or sample, so there will be this will cause some sort of deflection in this arm, resulting a current is generated, and that is supplied to coil, which restores it to null position. And definitely we have to put the arm at null position. This is important for maintaining constant position of the sample in furnace. So another advantage of putting this arm at null position is that so that the sample could be properly heated. The sample suspended in furnace from one arm is counterbalanced by tear. So to keep it at null position, So there is an option of tear, or and this process is done electrically. So there is a button by which we can apply tear, or simply by adding some weights in the reference pan. There could be several arrangements of balance and furnaces which are possible, and 4 of them are shown over here. These are A, B, C, and D. So here is the furnace, here is the balance, and here is the sample. If we see the arrangement A and C, so these are quite similar in what respect that the sample is in suspended form here and here. While if we see the arrangement B, so sample here is in top loading position. So this is the top loading position. And if we see the arrangement D, so sample here is in horizontal position. So these are the 4 different arrangements of balance and furnace. Next part of thermobalance is the furnace. These are generally non-inductively wound electrical resistance heaters. Means the function of furnace is to supply heat, and this is done on the expense of electricity. And the furnaces have following features. It should have a zone of uniform temperature. Means the temperature inside should be uniform, which is considerably longer than sample plus holder. Means the size of furnace should be longer as compared to the size of sample plus holder, and this can be simply achieved by using small size sample and small holder. Then heat from the furnace must not affect the balance mechanism, because this is very much sensitive. Means overheating can disturb the balancing mechanism. To avoid this, we often use baffles. Baffles, you can understand, these are the kind of barriers which are placed between these two. And what is the function of these baffles? They reduce the transfer of heat from furnace to the balancing system. Then the furnace should be capable of rapid response of heating and cooling rates even beyond the temperature of interest. Means we have set a temperature, so furnace should be able to get that temperature rapidly, and same should be in the case of cooling. So this rapid cooling could be useful for us, especially when we have to run a large number of samples. Then furnace lining should be inert at all temperatures used. Means it should not react whether the temperature is high or low. So to avoid this, we can use a tube. Now what will be the composition of tube? This can be made up of ceramic like alumina or molite. So this composition tube can be used at high temperature, while for low temperature we can use the tube made up of silica glass, and this tube will surround actually our sample and furnace. Another part of thermobalance is programmer. To measure the temperature of the furnace, we require some sensor, and for this purpose thermocouples are used. So here are the couple of thermocouples which are mentioned over here. First one is platinum thermocouple. This is actually platinum 13% rhodium thermocouple. Means there is 13% rhodium and 87% platinum. And this thermocouple is most suitable up to 1600 degrees centigrade. And another property is advantage is it is chemically inert. Another thermocouple is chromal aluminum thermocouple, and this is the nickel based thermocouple. It is suitable up to 1100 degrees centigrade, but the problem is it is more easily oxidized. So the signal from the furnace thermocouple is transmitted to the programmer, and the temperature is compared with that required by the program set by the operator. What does it means? The sensor, that is the thermocouple, senses the temperature of the furnace, and this reading is transmitted to the programmer, and definitely the person has programmed some temperature. So both of these temperatures are compared. If the temperature of the furnace is too low as compared to the temperature set by the operator, so system must respond by supplying more power so that the temperature of the furnace is increased. And if the temperature of the furnace is too much high, then definitely to reduce temperature, the power will be reduced. Now we are going to see the properties of an ideal sample which can be introduced in thermogravimetric analyzer or thermobalance. Thermogravimetry is most frequently applied on solids, means the samples are introduced in the form of solids. So this can also be the disadvantage of technique. Then the ideal sample should be small, means small in size, powdered form, and spread evenly in crucible. This technique is easy with pure and homogeneous compound. So if your compound is pure and homogeneous, so you will get good results, but it will become complex in case of if your sample is not pure. Then crystalline samples may behave differently from fine powders. Mean you run a sample, once it was in crystalline form, you get the result. Other time it was in the powder form, so definitely there will be difference in results, so reproducibility will be affected. Then sometimes it is also difficult to produce fine powder. There are some compounds or some samples which are different to convert, which are difficult to convert into fine powder. For example, thermoplastic. So we can't convert them into fine powder. So this is also the problem with some samples. Now this is just for example a typical thermogravimetric run that might be done under the following conditions. For example, the sample may be the calcium oxalate monohydrate. The crucible used may be of platinum pan. The rate of temperature is 10 Kelvin per minute. This is the increase in temperature. The atmosphere which may be used, that could be nitrogen, and nitrogen is fed at the rate of 20 cubic centimeter per minute. And the mass of the sample used is 10.5 milligram. So this is just an example. So dear students, this is all about the instrumentation of thermogravimetry. Thanks for watching this video, and if you like this video, then like it and subscribe my YouTube channel to get in touch with my upcoming videos. Thank you.